Alright guys, this is an updated video here for 10.2 and 10.3 together. I'm just going to kind of go over some of the big highlight ones. So I do have some certain problems picked out here. If you need the extra examples that I'm going to skip, I have those in the full versions. I'll have that linked as well. But otherwise, I'll get you through what you need to at least know for quizzes, tests, and homework and everything. So first of all, here's a cube root graph. This is actually the inverse of an x cubed graph, and that's because if you go and have y equals x cubed and then you switch x and y and then you resolve for your y, you would have to cube root both sides, and that would get you cube root of x right there. Now as far as nice numbers here for cube root of x, you want numbers that you can do the cube root of. So 0, 1, and 8 are going to be nice numbers that you can cube root. The cube root of 0 is 0. The cube root of 1, or what times what is 1. And then as far as the cube root of 8, or what times what equals 8, that would be 2. You can also do this here with negative numbers. The cube root of negative 1 is negative 1. And then the cube root of negative 8 is negative 2 right there. And that makes this graph right here. And you can keep extending those x values as far as you want. So typically the domain is going to be from negative infinity to infinity, and then the range will also be from negative infinity to infinity. These are kind of like the x cubed graphs as far as the domain and range goes. So they'll go left and right forever and up and down forever. It's just much flatter than a typical x cubed graph, and that's because you're reflecting across the line y equals x when they used to look like that right there. So anyways, yep, they're inverses of each other. X and y intercepts on a typical one is just 0, 0, and then 0, 0 like that right there. All cubic graphs will have x or y intercepts. It's different than the square root graphs that only had certain, like sometimes you could square root a negative or something like that. Every one of these will have an x and y intercept. So I think we'll do that here in a minute algebraically. Now the way I'm going to teach you guys, instead of making a table every time, so I'm just going to teach you the transformation rules and the pattern. So the big pattern for these, when the a value is equal to 1 or an implied 1 out in front, the pattern is going to be very similar to the x cubed except backwards here. It's going to be over 1 and then up 1. And then be careful here, some people mess this one up. It's over 8 because you're looking for numbers that you can cube root. Your over numbers are the numbers that you need to cube root here. So the cube root of 8 is 2, and typically you will not be able to fit too many other points. Like the next over would be 27 and then 3, which you're not going to be able to fit on too many graphs. And then this minus 5 right here is just going to move that whole entire thing right 5 units. So let's go ahead and try it out here. So right 5 units, that would be kind of I guess we don't really have like a vertex. I guess you can call that kind of like the center point. That'll be the h and k piece right there. So anyways, from there we'll go over 1 and up 1, and then over 1 and down 1. Okay, and then you would go also over 8, and then up 2, somewhere way out there, and then left 8. We can be more precise on this one, and then down 2, kind of like that. And all of these graphs should kind of look like flat versions right there of those graphs right there. So that much more flat than the typical x cubed graphs. Okay, now as far as domain and range on this here, domain and range on every single one of these is going to be negative infinity to infinity. You don't have to really do any thinking on those. As far as the intercepts go, you need to either look at your graph, which the x-intercept will be pretty easy. The x-intercept there is at 5, 0. And then if it's not at a nice point, like apparently we have 2 right here, it really should be somewhere there between 2 and 1 for this next point. So the y-intercept, we're going to have to plug in 0 for our x value. And if we do that, it'll be 0 minus 5. And that's just the cube root of negative 5. You could go and get that decimal point if you want, but for now I'll just say this is 0 and then cube root of negative 5 like that right there. And that would be good for your x and y intercepts there. So there's your domain and range, there's your patterns. The symmetry, you would just, I guess sometimes we'll ask you what point is it symmetric around. It's usually the point that it's they rotate it around and it'll be the same thing. These have what's called, I think it's even, or it's odd symmetry, which means it's got rotational symmetry. So a little bit of a thing from geometry there, but symmetry, I don't think we ask a ton of questions like that on the tests and quizzes. I guess if you put something about symmetry, just say it's symmetric around the point 5, 0. That would be good. Okay, B is the same thing, except we're going to move our graph right here. We're going to take that pattern of over 1, up 1, over 8, up 2, and we're going to move that down 2 units from the center. So this one will start right here. And we'll go over 1, up 1, down 1, left 1. Usually I'll make the center point a little bit bigger so I know where I'm starting back over from. I would encourage y'all to do the same. And then from that center point again, start back over, and then go over to the right 8, and then up 2, and then start back over that center point, go over left 8, and then down 2 from there. And you should get your graph right here, something that kind of looks like that. It slowly increases from right to left. It's a little bit steepest here in the middle, and then it kind of levels off towards the sides there. Domain and range, both negative infinity to infinity there on both of those. X-intercept, we could go and find the x-intercept by either plugging in 0 for y, or you could just look at it. Honestly, it's 8, 0. As far as algebraically, how could you go and get that? You could go and plug in 0 for y, and then you would go and get x by itself. You would add 2, and to undo a cube, to undo a cube root, you would cube both sides. That would cancel those out, and that would get you 8. And that's algebraically what that would look like. Okay, so 8, 0, the y-intercept here is actually rather easy to tell as well. It's 0, -2. And also it's symmetric around that point. Oh, my negative. Let's get that in there better. Well, of course I didn't leave myself enough room. There we go. So anyways, that's that. I would not worry about the table. Know your pattern. Your pattern is going to be the big thing. And here in a minute we'll go and do some vertical stretches there of those. But that's it there on those. Just like with the square graphs and the x cube graphs, we can do max and min of those over a given interval. And that's just literally plugging these in here for different x values and then seeing which one gets you the higher y value and which one gets you the lower y value. So just depending on where like these plus numbers are located here, the process is slightly different. So just make sure you're kind of looking out here for this. This will be cube root of 8, and then it's a +1 outside the radical, which means you need to go and add 1 after you do the operation here. So this will be -2 for the cube root of -8, and then -8 plus 1, it's going to come out to 3. And then we'll do the same exact thing with 0. We'll go cube root of 0 and then +1, that's 0 plus 1, which will come out to 1. So obviously the max is the higher of the two. And then, oh, you know what? And I did that wrong there. That should be -1. So actually that's going to change things. My bad. So that is the min. And then this one here is the max right there. So max is at 1, min is at -1, and that's about all you need to do there on those. Now the max is not always the second one, and the min's not always the first one. Sometimes you just got to see there at the end. So just make sure you check those. Let's try another one here with the plus number that's inside the radical, so that'll operate a little bit differently here. When you plug in the x value of -2, you're going to add the two things inside the radical first, which actually gets you 0. So that might be our min or max, not sure quite yet. The second one here, you'll go cube root of 6 plus 2, and that's going to get us cube root of 8, which comes out to +2. So 2 is the max, 0 is the min. Good to go there on that. So just make sure you know the difference between the process on those when the number you're adding or subtracting is outside the radical versus inside the radical. All right, moving along here. This one, yeah, we'll skip this one here. If you want the all examples and everything, I do have that worked out in the full example, so I'll also have that linked. But I would not worry about finding inverses here of these graphs. It's got a couple of weird steps there, so don't worry about that. We will use composition of functions to verify if something is an inverse or not. So that does come up on future tests and quizzes. So let's see what that might look like here. That is where you go and do f of gx, which means plug gx into f. Here's your gx function right here, the entire thing. We're going to plug it in for that x right there. And the order that these simplify in matters. So let's go cube root x plus 3. That's getting plugged in for that x right here. Then you still got a minus 3, and then you got a cubed here eventually. Now, there's nothing outside of this set of parentheses to distribute, so we'll go ahead and add the 3 and the negative 3, and that would cancel. Then you got all of this stuff cubed. When you cube a cube root, that would cancel, and this would come out to just x. Okay, now the next one here is going to be the total opposite here. We'll go g of fx. So that's f into g. So there's that right there. So we'll go x minus 3, kind of like that whole thing cubed, and then plus 3. More times than not, these steps here, they're going to simplify in a complete different order. So let's look here. When you cube a cube root, or I'm sorry, I guess I should say that as when you cube root a cube, those would cancel right there. And since it's in parentheses right there, that whole thing, you can go ahead and cancel that out instead of like foiling it all out together. And then you're left with x minus 3, and then you got the plus 3. Obviously, those would cancel, and then it'd come out to x. So then after that, then you can say that these functions are inverses, or inverses of each other. And that's all you're going to do there on those. So let's try another example, pretty similar one going on. So with this one right here, we have, okay, so let's go f of gx first. So that means g into the f, that means that whole thing into this here. Now, it looks like these are going to be inverses, but watch here carefully the way I write this out here. I need this entire thing, 7 times the cube root of x, that goes in for this x right here. Then I'm going to cube whatever that is, and then I'm going to divide by 7 here. And here's the issue. When you cube, you have to cube both of these things right here. Not just the cube root right there, but also cube the 7. That's where people make the little mistake here. You got to do 7 cubed right there, so I think that's like 343. Let me double check there on that. Pull my calculator. 7 raised to 3. Yep, that's 343. And then when you cube the cube root, that will cancel that out. So it's 343x and then over 7. And then when you divide it by another 7 right there, that's going to get you to 49x. And obviously that didn't come out to x, so these are not inverses, even though they look like they could be. Sometimes inverses, things that look like inverses, aren't going to be inverses. We see the 7 and 1/7 right there, so we think, oh, maybe those cancel out, and then the cube and the cube root would cancel out. But the way the math works, you have to cube that 7 right there. So kind of be careful on that. Sometimes they'll give you ones that are inverses, sometimes they're not inverses. Let me show you the other direction. We technically could stop there, but I want to go ahead and show everything here. Go ahead and put that away. So we could plug that in right there. That would be the cube root. Actually, write this here. This would be the cube root. Okay, you still got 7 out there, but then cube root. And then in for that x, we have the x cubed and then over 7. Like that right there. Now technically you can cube root the numerator and denominator separately. So this would get us 7 and then I guess times the fraction x and then over cube root of 7. And I know that 7 and cube root of 7 will not actually cancel, so this one would not come out to x. I'd pretty much stop right there. Right? And then you can say these are not inverses. And that's going to be that little piece right there. So those are a couple of different things. You know, we've talked about max and min, we've talked about x and y intercepts, we've talked about how to do a couple of the transformations. Then I guess the second lesson originally was designed to where you actually, instead of using tables, they wanted you to actually use the transformation rules, which I've already kind of showed y'all how to do there. So we'll kind of speed through this beginning section here. You got all this stuff here. Here's your generic cube root graph right here, where H and K is the turning point. I usually call it kind of like the center of the graph. And then A is going to do two things. It's going to either reflect if it's negative, or it's going to be a vertical stretch or strain. Alright, so we'll see a few where we actually have a stretch or shrink. We haven't seen one yet together, and you just change the pattern a little bit. So we've already kind of talked about this here, domain and range, negative infinity to infinity. And then x and y intercepts were both 0, 0, as long as there's no transformations going on right there. Now, since this +5 cube root graph right here, that's going to be the same thing as one of the examples that we just did. Just a couple of examples back here. It'd be kind of similar to B, except instead of going down, it'd go up. So I'm going to skip that one there just for time's sake there. Just trying to go through just, kind of the minimum stuff so we can understand like all the different things here. So let's skip over here to see what the vertical translation. Haven't done this one yet here. It says graph both of these on the same set of axes as the parent function right here. And we're just doing that so we can see the difference there in them. Notice that one's got a positive, one's got a negative, so it'll look slightly different here. But here's what you're going to do when you're doing these here. I want you to take your pattern, which is over, and remember, you're cube rooting the numbers that you're going over. So it's over 1, up 1, and that goes both directions. And then it's over 8, and then up and down 2. Okay, and then what we're going to do now is we're going to take that pattern here, and we're going to multiply it by 4. Okay, and that's because you got this number out here in front. The second one here would just go down instead of up. So, we'll see what that looks like here in a second. But this one would be up 4 or up, I guess, 8. Now, unfortunately, they didn't give us the greatest grid in the world here for this. So I'm going to make each little tick here on the grid. Whoops, I'm going to make them by 2s. And now that we got it labeled that way, now we can go and, plot everything here. So let's do this here. So over 1, up 4 would be kind of like that. Of course, you got 0, 0. I'm going to go backwards 1 and down 4, which should be 2 ticks. So it's very steep there in the middle because of the vertical stretch. But then eventually, when we do the over 8 and up 8, it's going to start kind of leveling off here. We're really not going to see it level off a ton, but here's how I would draw it here. Since it's a cube root graph, you do want to show that it does level off eventually. So it's just much steeper there in the middle, and then eventually the ends kind of, level off a little bit. So that's that one. If you wanted to compare it to the parent function, I guess I could do that here in blue. That'd be over 1, up 1, kind of like that, and then over 8, up 2, kind of like that. So we've significantly increased the steepness here, especially in the middle. So that's kind of like what the graph would look like. The one that would be a negative version would just go down instead of up. It would look something kind of like this right here. Like this orange graph right here. So real steep there in the middle, but then kind of going down like that. So as long as you know how to take that pattern and multiply by whatever the vertical stretch is, you're going to be good to go. So I think this next one here I want to practice with a fraction out in front. So we'll do one of those. And then I think we're going to be pretty close to done here. Let's see here on this one, you got the negative 1/2 and the positive 1/2. So I guess let's do the negative 1/2 first. So we'll take that pattern. Remember, numbers that you can cube root. So over 1 you can cube root that. That's up 1. Over 2 you can cube root. Oh, I'm sorry. Can't cube root 2, not a clean number. You can cube root 8, however. That'd be up 2. Now let's take these and multiply by negative 1/2. Okay, if we did that, that would be down half of 1 is just half, and half of 2 is 1. So it's going to be a very, very flat looking graph when you do this one here. So let's see here. Yeah, like we did before here, we'll make everything 2, 4, 6, 8. Okay, so we go over 1 and then down a half, which is kind of like a quarter of a tick right there. So I'll do that on both sides. It's kind of hard to get it real precise there since it's not the greatest grid in the world. And then I guess we could go over 8 and then down 1. So that would look like this, a very, very flat looking graph. Okay, as opposed to the parent function, which was a little bit, whoops, over 1, up 1, over 1, down 1, and up 2. So there's the parent function. So the parent function is just a little bit taller than this new stretched one. And of course you can do the 1/2 one right there if you want, but just for time's sake here, I'm going to get through the rest of this here. So that is that right there. If you can do all the different variations, then you should be able to combine it all, which I think this very last example, we're going to combine everything we've done here so far and graph that. And then they got kind of like a word problem element to it, so that'll affect, what the main overall graph will look like here. But let's pretend we don't have any context, and then we'll just do all of this here, and then we'll tie back to the context here. So you got a vertical stretch going on right there. You got a left 1 and then an up 4 going on as well. So I'm going to go ahead and sketch that there. So what was it, left 1 over 4? Okay, left 1 up 4. There's that. There's kind of your starting or center point right there. And then you got your pattern. And your pattern is over numbers that you can cube root. So that's over 1, up 1. We're going to change that. Over 8, you can cube root 8. The cube root of 8 is 2 right there. Except we got a vertical stretch by 2. So double all of those numbers. So we'll go up 2 and up 4 from there. Okay, and that's from the center point. Always start that back over at the center. Make it a little bit bigger so you know where you're starting back over from. So over 1, up 2 would be kind of like that. And then over, what was it, 8? 1, 2, 3, 4, 5, 6, 7, 8. And then up, I think 4 right there. I think that's good now. Yep, that should be good. And I think that would be it right there. Now, since they have this tied to a context right here, this models the monthly profit FX in thousands of dollars at the number of months X a cafe opens for business. What is the graph of the function? So you could go and do this full graph right here, but when it's tied to the context, you really can't have like negative months right here. So really the only part of the graph that you should have highlighted is that part right there. So if you want to go and just like, I don't know, maybe do like kind of like a little dotted line here for this piece here, just erase chunks of it right there and then kind of focus in on the highlighted part. The highlighted part's the main part of the graph that you would want to look at in this context right here. So yep, that would be the graph right there. And then starting at 0, months, I guess, you got a certain profit and then it slowly increases over time. So that's going to be it there on that. We've got a small handful left here. I think we're going to do some writing our own equations, and then we got like a word problem where we go and plug in. So anyways, let's write the equation for the following right here. We got a cube root parent functions reflected over the x-axis and then translated 3 units right, 2 units down. So it's got the reflection, so that's one of the elements for the A. You need a negative out in front. They did not put any, they didn't put any stretches or anything, so we're good to go there. Oh, one thing, make sure you're using the correct parent function. We've learned quite a few over the last few days. Make sure you're using a cube root function and not a cubic function. Cube root function, so I should see some type of radical. Right 3 should be -3 inside the radical, and then 2 units down would be -2 outside the radical. And then you can do like a function notation right there. I guess if you put y, I probably wouldn't count off on that. So that'd be good there. Now sometimes instead of giving you, like a described thing that happens, sometimes I'm going to give you a graph. So here's how you're going to approach this. It's a cube root graph right there, and they're telling us that because of this right here. So we can go cube root, put you an a value out in front. We don't know the vertical stretch, and we don't know if it's moving right or up and down. So we'll put h and k. Now the good news is the h and k is actually 0, 0, which means I get to plug in zeros for those. That's kind of nice. Okay, so I'll have a -0 and then a +0 there eventually. Now as far as an x comma y, why don't you use this point here that they gave us? Let's just, I guess I already got it labeled here for us. Let's use x comma y for that. So I'm going to plug in -8 over here for y, and then I'll plug in the +8 right there for the x. And then we'll just start seeing if we can get a by itself. That would be the cube root of 8, and really you don't need the +0 at the end. Okay, cube root of 8 should be, what is that, 2? So that'd be 2a cubed equals -8. We can divide both sides by 2. That should be -4. And then I guess we could, let's see here. I think I messed something up here. Oh, I cubed, okay, right there. I already cube rooted it right there. I don't need that cube there. My bad. So that actually just tells us a is -4 right there. And once you get that, you can plug back in. A is -4, and you can